Okay, in our first lesson in chapter 2, we talked about conditionals and how they're stated using if and then, and that the converse is their opposite. So today we're going to talk about in lesson 2.2 biconditionals, and we know that this prefix bi means to. So a biconditional is when a conditional statement and its converse are true and you combine them into a biconditional statement. Now, you can simply use the word and, but it's appropriate in geometry to use the words if and only if. And here's your reminder that yes, I do want you to write all of these examples down in your whisk. All right, so my first example, a conditional statement in geometry would be if two angles have the same measure, then the angles are congruent. The converse, like we talked about the previous lesson, if two angles are congruent, then the angles have the same measure. So the biconditional, I'm going to combine both of them using if and only if. Two angles have the same measure if and only if the angles are congruent. Now, you can also do the opposite, which is separate a biconditional into parts. You can write this biconditional as two conditionals that are converses of each other. So I started here first with the biconditional that says a number is divisible by 3 if and only if the sum of its digits is divisible by 3. So I can separate that now into if a number is divisible by 3, then the sum of its digits is divisible by 3. And then the other way around, I can say if the sum of a number's digits is divisible by 3, then the number is divisible by 3. Now, in geometry, you may see it written like this in a symbolic type form. The conditional statement might look like this, a P with an arrow to Q, and you read that if P, then Q. That just means if this is true, whatever that is, then this is true. And then when you write its converse, you'll see a Q with an arrow pointing towards P, and that simply just means if Q, then P. If this, whatever Q is true, then P is true. And then when you see a biconditional written in its symbolic form, you'll see a P with the double arrow going back and forth, Q. And you read that as P if and only if Q. Now, in geometry as well, we have definitions. And what you need to remember when you read a geometric definition, it must be clearly understood terms, already defined, things that we already know. Precise. Avoid words such as large, sort of, or some. You've got to have precise words in geometric definitions. And they need to be reversible. They can be written as a true biconditional. So I put some examples down here of a good definition and then not so good definitions. All right, so to show that a definition, this definition of perpendicular lines is reversible, we should be able to reverse it into its converse and write a biconditional to show that this definition is a good definition. All right, so perpendicular lines are two lines that intersect to form right angles. So the conditional statement would be, if two lines are perpendicular, then they intersect to form right angles. The converse of that is, if two lines intersect to form right angles, then they are perpendicular. And then the biconditional, if two lines are Two lines are perpendicular if and only if they intersect to form right angles. Now over here in red, I asked, is this following statement a good definition? An airplane is a vehicle that flies. No, it's not a reversible definition. We can't do a converse and it won't make sense, or it's not the only one vehicle that flies is not just an airplane, because a helicopter is a counterexample. A helicopter is a vehicle that flies, but it isn't an airplane. So that would not be a good definition of an airplane. A triangle has sharp corners. Is that a good definition? No, because it uses the imprecise word sharp, and it is not reversible. You can't turn it around and do its converse. So we will be working with writing good biconditional statements and deciding if definitions are good definitions or not. And I'm just going to end with my little picture of my Spanky dog. I just threw that in there because I thought he was cute and he'd make this lesson a little more fun. Thank you.